first of all introduce what the project is about, and also we'll cover, we present the EMR4All kit. The EMR4All kit that we called kit by thing. It's just a combination of all-in-one package of the tools that we are working forward, but we go into that. So I will present that part, and my colleague Kevin will take the part of the synchronization future, which is far more advanced to sync data coming from the health facility to be accessible for either we tested at the cloud, but it can be also accessible for a central for any other remote server. So the goal is to present you the update where we are from before we go into production, deploying production material, making a little bit ready for deployment. So I'm going to share the screen and explain a little bit about the project and what it is about. If you have a question, as I noticed, you can send it on chat. We'll see it, and then we'll be able to cover it. So the idea came from the problem statement for any other innovation, any other start for a problem. You need to address a problem. And coming from, first of all, our own background, our own experience in e-health portfolio, working in different contexts, different environments, we realized that there is a need which is not covered, which is to provide an EMR solution, electronic medical solution that can be adapted to rural context area, not only rural context area, but also some other areas which might be emergency interventions, which can occur at any place. And the team need to go with a device that can enable quickly monitor and track patients. So this has been happening in several projects that we personally have been engaging, where like migrant health, where you are affecting in both sides, not only looking at only middle income country context, but also in developing countries as well. I can take an example, what is happening now in Europe, in America, where there are migrants going, they are sitting in the town, and they will need some medical intervention, some medical NGOs support those migrants, but they have some challenge of using a tool which can be easily carried out on the field and track patient record over the treatment time. So many other solutions, there are sub-solutions which are already there. We can say we come from bringing, like inventing the way, but we brought knowledge to improve what the needs and the problem which still delay, still not have yet been resolved. Saying that in that regard, so especially in the areas where you imagine a health facility in a rural environment, rural settings, where to carry a server, a heavy server, is costly in terms of logistics, we can say that. And also maintaining it requires people to be able to work it around. And this is leverage our sign of say, okay, why can you seem to have a solution which is small, which can be portable, easy to carry out, easy to deploy, and which can work at the same level with the same functionality in terms of processing, in terms of capacity as a huge server. And both of us came with that idea, okay, we are all OpenMRS developer per se, and we said, why not use a software that is well known, a software that is well used into the context of we just providing infrastructure. So that's where we come from, as I highlighted the problem. So there is a high cost of bringing server to the field. So there's a limited experience to have maintain this server. And especially imagine there is an outbreak occur in a place where there is a team which go there for emergency team to start surveying, start treating patients. So they do not have time to carry huge server infrastructure in the field. And sometimes they might fall in challenges in places where there's no internet, which was one of our key goals also to bring an infrastructure that enable working totally offline at a health facility when treating patient, when looking for patient information, following a visit. For those who have already knowledge of electronic records, they understand about it. So this tool could be more practical. So any place you go, any place you just deploy the tool and start, just plug a button, not plug a button, as we can say, but you just start it and then use it. That's one our goal. So solutions should be cost effective. There are yet other solutions which are on the market, and we aim is to provide the most cheapest solution, most affordable for any health facility, which can be flexible to move, easy to carry out, and also should be a little bit compacted so that when they come to a health facility that have limited resources, to be able to also not take a space. And we should also look at solution of the one that increase reliability, which mean should look at more trust or more security. So we just not provide technology. We can be, we are ITs and we can be medical. So there are certain criteria that need to be considered while it comes to use technology as others produce it. So these are challenges and solutions that we thought about. And then we come out to set up what we call the EMR4All project. Why project? Why not solution? First of all, before talking about the solution, we started as a project. We had a vision, we had an ambition to achieve. So we walked through that process in terms of technology development and in terms of needing the real need for improving electronic medical record. But before diving into that aspect, and I would share a short poll question, one question, and I would like just if you can just interact to make like a choice of what you think is more related to the challenges, and then we move forward to the next level. So I'm going to activate the poll on your. You might see it on your screen, and just say what you think about in terms of challenges, in terms of for generally speaking for the EMR, for not EMR, but like EMR in general. The question is, what is your biggest challenge with the current EMR system? So you can vote, and we try to build from that as we go forward for the next question. Did everyone yeah, great. Yeah, wonderful. Well, we have a big percentage. Wow, it's coming up. That's really great. Oh, wow, that's interesting. So if you have others, you can put it on the chat. We'll catch it from there and then complete the... So we give ourselves a few minutes for those who have not yet voted. to do it. Yes, please, please, please. We need to see your contribution there. Please, 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 come through, come through, come through. Yeah. So we have, the implementation challenges there. Insufficient support is look to be more ranked as slow and reliable data access. Come as a second. Okay. Right. So really, thanks for this this vote. So we try to build from our presentation. We say want to be more flexible and adapted to the context. So there's someone is coming. So give 5 minutes so to get everyone inside, everyone participating. Wow, security and data is more portable. That's really important. Thank Dan for that. Right, thank Joshua for the contribution related to data decision making support, dashboarding. That is key also. Anyone else? Have you all voted? Oh wow, great. So moving from that, building from that, so we try to adapt our presentation according and also be more reliable. Not many people are looking of what are these solutions, want to see the device, but we'll get there. Because if we want to provide a solution, a technology, we want to make sure that it meets it solves a problem. So we just not provide a solution, but to make sure that it meets what need are. So we have the sufficient support for rural. That's really key, because that's come to the point that there is a big issue in terms of the remoteness, the consideration of places which are really difficult to access. It's really challenging to access, and beyond that, I accept that. So data access is also a big track, because most of remote area facility, not only health centers, but also mobile clinic and all the intervention have those challenges. So now coming from that, we try to adapt to say, okay, why EMR4All? Why did you choose first OpenMRS? As I said it's an open source adapted to well-known and well-distributed, and which have made its own journey in terms of progress, in terms of development. So from starting from years and vision, so it became more reliable. And since we are all also part of member of OpenMRS, it's not just we select that solution per random, but we have advanced use of it. But let's say we at the EMR4All, we are providing infrastructure per se and also being supported. So first advantages for what you highlighted the problem. There is a problem of working offline. So let's say there are some challenges of where it comes to the health facility, which have to operate in the context without internet. There's a need to have at least a working offline solution. There should be an improved way of data collection, as they are most of have been relying on still at a paper base. And I imagine when I was working in some organization where it happened to improve to intervention for emergency intervention. So we had thinking what solution to provide, DHS2 or whatever. So, but they do the work. At some point, there were need of how can we collect this data while being offline, and how do we improve this data collection, this patient follow-up, at least in a remote area settings. So these are kind of questions. So there should also be when you deploy this EMR. This should have, and the mini device should have at least to keep the power extends, and also enable data to come out from the health facility. So now we came about with Raspberry Pi, which I'm going to present, and then showing you what is it about before we go to this aspect. So I'm going to quickly stop this presentation and come to my sorry, bear with me. No, it's not this. I'm not sharing screen. Not sharing screen. Should stop this. Okay, right. Okay, so the Raspberry Pi, as many knows, it's a teeny server like this. This is just one box, that box of what we can buy anywhere in Amazon, in whatever, in wherever you can get it, and you have your Raspberry Pi inside. So this one, you can, it runs, we chose Pi 5, which is an earliest version, running a processor of 2.4 gigahertz within the RAM of 8 gigabytes. And on which top, many of known, sometimes Raspberry Pi Basic run with SSD cards, teeny card. But the SSD card has limitation as well. You can go 250 gigabyte in terms of capacity of disk, up to 500. That's the most limit. But we there is also an extended type of memory, which is more large and go up to 2 terabytes. So it's not SSD guide, it's called PC cards. So we try to build up the system with both infrastructure for the very limited resources health facility. Anyone can access to using this SSD. And to be also in terms of reliability, this system in terms of robustness, if I can say that way, excuse me, in terms of security, Raspberry Pi has been provided reliable safety in terms of information, like Windows and computer. And the other benefit, it's run Linux, so it's not easy to hack or easy to be affected by viruses. So the other aspect which we came about is to run this Raspberry Pi with a power bank. So what we come out with a box like this, as you can see, which in which we poured in Raspberry Pi, which you can see here, the one that I presented that you can buy is at in anywhere to the distributor. So we put it in the box and we associate it with also a power bank. So the power bank serves to run the Raspberry Pi so that it keeps the power up time. And also we chose a type of power bank which is called pass-through. Pass-through power bank means you can charge the power bank and also while it's used. But we also, in terms of material specification, we have two type of power bank that we set. The one that is running can enable to run with a minimum power consumption time, and the one that can go up to 72 hours, which is more robust and have a bigger case than this one. So when we spoke about a box, we try to think, okay, instead of people carrying it on hand, different compartments, it's a bit, maybe it's a bit challenging. We said, let's put it also into a compartment. So this compartment is, we start that the first version, but we are aiming to improve it as this is like a prototype, but we try to put everything in the box so that you just need to take the box, you go at the health facility, you deposit somewhere, and you start using it. So it's more practical for like emergency intervention for where it comes to, you have a mission that need to use it quickly. So you just have your box, you just bring it and turn it on, and then take and start using it. So in terms of Raspberry, how it works, how it operates itself. So just to give a note related to the book that if I go back from what I said, so you have a capacity of running it up to 2 terabytes in terms of let's say this, we can say memory. So processing time is very fast. It complies OpenMRS, BAMNI, and most of other electronic medical records. So the power bank is chargeable, so while running it. So we are deploying another version design that we'll be explaining later, which will enable, since this will be used for in most of African countries or middle income country or anywhere, which is exposing. I'm very sorry if I'm trying to use some word which are not appropriate, because I'm myself from Africa and bear with me about. So yeah, saying it will be used in exposure places where there's heat. So we are going to improve the version by putting some more air conditioning to put more air on it, and also trying to improve the box to be more look and feel, and also putting solar panel. We are also having a version where we want to have a solar panel, so just carry it on the field and the ground and just start using it. So quickly presenting how it works. So I have my Raspberry Pi turned on, just plug it and turn it on. And you can use any type of device. Here I have a tablet, which just a simple tablet that you can use. So you can use a mobile phone, you can use your computer. So we integrated in the this solution an access point router. So you don't need to have another internet switch, but you can also switch it to internet for different infrastructure. If you have already a setup, and depending on the setup, you can also plug it. So, but we try to make it for this version a little bit for use for any type. So you just plug it and just use it. It doesn't request, it's not connected this tablet to internet, but it's connected to my Raspberry Pi, which is broadcasting. So if I have my tablet, I have my Raspberry Pi, wherever there is no internet, I will operate. I will follow our patient, and it can support many devices. So it can be in the places, where there is it's a big hospital or places where locations are different, you can add an extender antenna on it that we also think to integrate. But for those knowing about the OpenMRS, it operates very seamlessly. We started working on development side 1 year ago, where we tested different type of version of Raspberry Pi. We had failure in that program. We have even version of we came about to Pi5 because we found that it's more reliable and fit with the purpose in terms of operating system itself. So we have partners who have expressed the need of piloting the solution, and some of them have already acquired equipment, which is not this one, but Raspberry Pi that's normal. So our need was coming from development. We wanted to make it, instead of expose it to the usage, first of all, to ensure that the development is ready and sufficient done to be utilized. And this is why we did not put it directly into exposure, but it's part of follow-up of this webinar that will present a plan, because we want to run a pilot, we want to put it in an in vivo test, so that we make sure we collect feedback before we run the production. And this is why we call the pre-launch. Yeah, the full charge capacity is something that we'll expose as well. We put into practice after this call. So we'll need to have volunteer partners. We have already some who already signing to test a solution. And we would like to run some pilot in a different context, in different area for exposure. So before we get feedback and improve, even this, when did this test, we look at power consumption, we look at internet coverage, sorry, wireless coverage. I can't say internet because it's running offline, but we look also internet coverage when it comes to push data, which will be the second point of this presentation. But how far is the wireless, local wireless works, and also usability, user friendliness of it. So I give the floor to Kevin to present the part for data synchronization component, which is a very important part of this project. And I can say, you may have known, maybe we are not the first to start this journey, but I can say we have far more advanced, especially to push data from the field out to the cloud server, coming from these devices running offline itself up to the cloud server. We'll make a live demo. And I had a question about, bear with me, power heating, subheating stuff. And we say that we are working on the case to improve it, to be more security, because we are going to deal with the medical people and also patient data. So we need to make sure that from the case itself, for example, we are going to print the case on ABS. So it's more, it supports heat and at higher level. And we also making sure that, as I said initially, that we put more air condition fan in to keep. We have also on the case, we also put a monitoring somewhere here, so someone to monitor what is the level of heat, or if the power bank is requested to charge, it will have some signal around. So it's something that we are working on and should be ready before the end of this year. To ask my colleague Kevin to come through, who will present the part from the sync module, and then I will not do it as a presentation slide, but I wanted to make it a real live presentation. Yes, please, Kevin, come in, and the floor is yours.
For that wonderful presentation. Yeah, so I'm going to share my screen. So I have to be moving about the screens a little bit because I'm sharing this other screen. I hope you can see when I shift. And that is the screen that is running the Raspberry Pi. And this other screen, this is the screen that is showing what is happening on the cloud. So Benjamin, can you confirm that both of them are visible when I switch?
Yes, are visible. So the cloud one is 50.17.248, okay. And the other one, can you switch? It's local host, supposed to be local host, right? All of them are fine for you. Yeah, thanks.
That is a local host. So that is the Raspberry Pi. This is just the window that I'm using to access the Raspberry Pi device. I was creating this webinar patient when we were during the discussion. So because I didn't want to take a lot of time creating a patient and all that stuff, we just want to see how the data is synchronizing. But so from what we can see here, we have the webinar patient created on the Raspberry Pi, and I was having a visit created for it as well. So the visit is still active, and I was just capturing some vitals at the bottom here. So I can go ahead and capture a visit node and probably give him a diagnosis. Let's say, for example, malaria. Severe malaria with a simple node. Fever. So yeah, and then just save that as a diagnosis. Severe malaria. And yeah, so we have those two. We can admit the patient to inpatient. Can admit the patient to inpatient ward. Inpatient ward. So you can see the encounters building here. And then I can just let's pretend that the patient is well, and we can exit them from the inpatient ward, and then just end the visit. End the visit. So the visit is no longer active. So that is all the information I have for these patients on the local computer. You can add other things like conditions. You can add a condition. For example, let's say the patient is diabetic. How do you put that? Diabetes. So from the patient dashboard here, you can see the patient has a condition here, diabetes. You can put an allergy. Let's say the patient is allergic to what? Penicillin. Used to be a common allergy olden days ago. Maybe it still is. And an allergy has a reaction. So if you put an allergy like penicillin, they will have a reaction, probably like fever. You can add a note and say patient is allergic to penicillin. So we'll try to synchronize these patients' records, see if they can get into the cloud server and see all these information there at the cloud server. So here is the cloud server. We haven't synchronized that patient well yet. It was called the webinar patient. It's not there. So to do that, we have a custom sync service that we have developed for this purpose. It's already running. So there are two parts of it. There's the part that is the service that is running on the local computer, and that is the Raspberry Pi in this case, the local device. And there's the API that is running on the cloud server, and that is the more complicated one. And so to do it, the service is already running, but what I will do in this case is just to start it manually for the purposes of demonstration. So when I run the service, you will see it responding with what it is doing, like sending data and what type of data it is sending. And when it gets a response, it indicates whether the data has successfully synchronized on the other side, and then moves on. So that is what I will do now. So this is what these are the logs we are getting when the synchronization is running. So the device ID, basically it started at this time, from what you can see, 502. So the device ID is called Raskevins, but that is because we are working with Raspberry Pi. So it's not because I'm a Rastaman, but I'm also, yeah, you can be a Rastaman. So it's just doing everything and sending the data and giving responses for each of one of them, whether it succeed or not. Usually they will just succeed. And then once it is done, we will go and check on the cloud server whether everything is the same as we have on this local device. So still working. It's still working. I'm still working. I think it's done at this point. So when it is done, you can see there it says end. All specified tables have been checked. We haven't seen any errors so far. So that means everything is good. So this is what it would do even if you had many patients in there, even if you had, a lot of patients in there, it will be sending the data in batches. So let's say like 100, and then another 100, and then another 100. For each 100, it will do all these for all the patients in one batch. Now, onto the cloud server. Because we just created a new patient, there is one more thing we have to do on the cloud server, and that is rebuild the search index. OpenMRS does this automatically on its own, but it only does it once a day. So it means whenever you do synchronization of patient information, the patient demographics, so to speak, they will probably appear on the cloud server the following day. But you could trigger it to appear immediately by doing rebuilding the search index. If it is not patient demographic information, the synchronizations, the synchronized data will just appear immediately. So to build the search index, this is the all UI. So we have to approach it that way. So you go to System Administration, Advanced Administration, and it gives you the all UI. So from the all UI, there is this maintenance section where you have the search index. This is where you go and you rebuild the search index there. So rebuild the search index. So OpenMRS doesn't advise that you rebuild the search index frequently, or probably not when people are working on it. But yeah, this one is already done. So if I go here and search for the webinar patient that we were talking about, you can see the patient here synchronized. I can open the details and they will start loading. So we can see we have the patient the way we were working on them from the Raspberry Pi. The diagnosis, malaria, the recent visit, the vitals, the observations, every other thing. We have the conditions here and the allergies, and then we have the visit data. So we can open that visit and see what happened. This was the visit, and we had the vitals taken in this encounter, and we had a visit not taken in this encounter. Admission is simple admission, doesn't have any observations. And discharge is also just discharge, doesn't have any observations. So that is it, just showing you how all the patient information can be all synchronized from the Raspberry Pi to the cloud, if need be. So that is it for the synchronization. Thank you.
So we presented the key problems. We presented where this solution can be complied in limited access to medical setting. I will share this presentation. So the aim to achieve to have a rapid deployment, adaptability, telemedicine enabled, scalability, future, also comprehensive disease management. I explained it earlier. So we explained about the kit where we want to improve. We want to make sure that we work on more security, advanced more security in terms of data protection and in terms of also security of devices. But we want to come out in terms of improvement planning. We have a user-centric design in terms of the boxes and also the sync module. As you see, instead of writing, we want to sync to create a batch file that will be synced. We need to deploy it to make sure that the solution can be deployed in the versatility setup. Either in a mobile clinic, rural clinic, refugees camp, emergency international scenario, we want to export it so that it's fit for that purpose. The heating control is part of that we are using. We are working with our designer who's part of this meeting as well. Who's working on temperature with support on that, including solar panel, And also we want to look at feedback mechanisms for maintaining the device while running if there's a troubleshoot. We have already set up remote control, so we want to make sure also to have also the data protection and also stuff being done before, because we'll be exposure to deal with patient information. So for the end, we can say we have covered the benefit about the continuity of care, about the enhancing disease surveillance, improved collaboration for different medical. We have multi-site capability of syncing. We also cloud integration. So I can say the goal is to get more user-friendly, scalability interface, quick deployment, improve our connectivity solution. Now we have we'll plug it dongles, and but any connection that you may found on the field will be able to sync. So even 2G will be able to sync. The data security measurement, which is very key, that we are very keen about it. We will not lack on that side before we go for production. I want to thank all of you for being so patient for these 2 hours. It's so long, but also for interactive participation for this webinar, which we may have to close now, early before, but we really thank everyone. Thank for your contribution. Thank you for having accepted our weaknesses, our limitation as well as a human being, and we are very grateful for your support and for the next level that you will bring in. The time you go and sing, the time you go and find. Meeting next session will make it short because we have now advanced, and we'll keep you updating on the different share. So if you want to see more on about where you can visit our website, you can the website that we created. We can't say it ours, but we created for the purpose of the project. Really, thank you, all of you, thank you, and we look forward to updating you from the next level. We try to share to all of you some update and where we are from. The record will be also shared for those who want to review it and have more in-depth understanding. I really thank you, and I'm personally applauding you for being so interactive, so practical, so open up, and very, very thank you. Look forward to see you to the next level. Appreciate it a lot.